Welcome. In this video, we are going to use the limit definition of the derivative to find the slope of the line tangent to this function here at this point. Then we're going to determine the equation of the tangent line in this form, that is in slope-intercept form. So first, let's recall we have two definitions we can use. We can define the derivative at a point A, that is f prime of A, as the limit as h approaches 0 of f of a plus h minus f of a over h. Equivalently, we can look at this as the limit as x approaches a of f of x minus f of a over x minus a. Now, it doesn't matter which definition we use, either one will work, so I'm going to use the first one. So f prime of -5, well, that's equal to the limit as h approaches 0 of f of -5 plus h minus f of -5 over h. So we have the limit as h approaches 0. And now our function notation here tells us to get whatever is inside the parentheses and replace it wherever we see an x. This does not tell you to distribute the f. Don't do that. That is a misinterpretation of function notation. So this becomes 25 minus -5 plus h squared. That's for this first one. Minus 25 minus -5 squared. And that is for this one. And now we're going to divide this entire quantity by h. So this is the limit as h approaches 0 of 25 minus 25 minus 10h plus h squared. Please don't omit these parentheses. If you just omitted them and changed this to a positive and didn't distribute, or didn't multiply this out, you'd be incorrect. So please leave these parentheses until after you have distributed this negative, because remember, so much of being a successful calculus student is getting the algebra right. Now from that, we're going to subtract 25 minus 25, and then we're going to divide this entire quantity by h. Clearly that's 0. So this is the limit as h approaches 0 of 25 minus 25. Now I'm distributing this negative. So I need a positive 10h and a negative h squared. Plus 10h minus h squared over h. So this is the limit as h approaches 0. And I'm feeling a little crowded here, so let me move this. There we are. The limit as h approaches 0 of 10h plus h squared over h. We can now factor out an h in the numerator since they share that in common. If you went ahead and crossed these out, you would be wrong. That is incorrect cancellation. You cannot cancel across division. This is division here, so you cannot cancel division across addition. Now this is multiplication. Multiplication and division undo each other, so we can absolutely cancel these out because h divided by h is equal to 1, and we're left with the limit as h approaches 0 of 10 plus h. 0 is now in the domain here of 10 plus h, whereas when we started, 0 was not in the domain, since that would provide us with a 0 in the denominator. So this just becomes 10. This tells me that the slope of the tangent line to this function, y equals f of x, at the point -5, 0 is 10. Okay, now let's look at the second part of this problem. That is, let's actually find an equation for the line tangent in this form. All right, as you can see, I just scooched over all the work and left us some space here. So I know that my slope of this tangent line is 10. So I'm going to use the point slope form of a linear equation. That's y minus y naught equals m times x minus x naught, where my points, in this case x naught comma y naught, I'm going to say that's negative 5 comma 0, since I know the line tangent to this curve with this slope is passing through that point. So y minus 0 equals 10 times x minus negative 5. So this is y equals 10 times x plus 5, or just y equals 10x plus 50. Here's wishing you a whirlwind of wisdom after watching this video.